Welcome to classes by Inspire Physics. Today we are going to see electric flux as well as Gauss's theorem. Electric flux means, see, if we have a charge or a uniform charge distribution, the charges will produce electric field lines. The electric field lines can pass through an area. So through a particular area, how many field lines pass in the direction of electric field, and that is called electric flux. Say we have an area shown like this, and we have electric field lines. See, these are the electric field lines. These are the field lines, electric field line, uniform electric field lines passing like this. Okay. See, these are the electric field lines passing through this area. Okay, like this field lines are passing in this direction. This is the area vector. What is the area vector? This is a directional electric field. See, this is a directional electric field, and this is the area vector, d vector. Okay, so this is a directional electric field, this is the area vector. Through this circular area, the field lines are passing. Now, if theta is the angle between them, then the total number of field lines passing through the area in the direction of electric field is called the electric flux. And we have a symbol. Flux is having a symbol d phi. The small flux through the small area di is, the d phi is equal to, we can define as E dot dA. E dot dA, and it is equal to d phi is equal to E into dA into cos theta. Okay. Then total flux to the entire surface area, we can say phi is equal to integral closed surface integral, we can say E dot dA. Okay, this is the equation for total electric flux. Total electric flux through a particular area in a directional electric field. Now that is called electric flux. Now according to Gauss's law, suppose we have a charge. Say we have a charge Q. It is enclosed in a closed surface. We can imagine a closed surface like this. Just we can imagine a sphere. Okay. Then what happens is charge will produce electric field lines like this in all the directions. Okay. We need to find actually what we need to find is, see, let R be the radius of the sphere. The total flux, total electric flux passing through this sphere, through the entire surface of the sphere. See, we need to find the total flux. According to Gauss's theorem, the total flux coming out of the closed surface, total flux will be equal to 1 by epsilon 0 times net charge enclosed. Net charge enclosed by this sphere. Okay, if Q is the net charge enclosed, the total flux through this sphere will be equal to 1 by epsilon 0 times the net charge Q. That we need to find out. Okay, now we need to prove this. To prove this, what we can take is, we can take a small area. So first we will see the intensity at this point. See, intensity is directed away. If R is a distance, what is the equation for intensity? Intensity is equal to 1 by 4 pi epsilon 0 Q by R square. Okay, we will take E dot dA. See, when you take E dot dA, what is E dot dA here? E dot dA. E and dA. So let us take a small area here. This is the area, and this is the area vector along the same direction. dA along same direction, both are in same direction. See, then it will be equal to E dot dA is equal to E into dA into cos 0. Cos 0 is 1, so you will get what is the value? It is equal to E into dA. So E into dA is a flux. I can say it is a d phi. Then what is the total flux? The total flux through the entire surface equal to integral E into dA. Okay, we need to find this. We need to prove that this will be equal to 1 by epsilon 0 times net charge. That's our aim. Now what we do is E, we have the value. Flux of I is equal to surface integral. See, E is equal to 1 by 4 pi epsilon 0 Q by R square into dA. Okay. Now all these things are constants. You can take it outside. Say phi is equal to Q by 4 pi epsilon 0 R square into surface integral dA. See, dA means a small area. It's a portion of a small area on the surface. When you take the entire surface area, you see what is integral dA? Integral dA will be equal to the entire surface area of the sphere. What is surface area of sphere? It will be equal to 4 pi R square. So we need to substitute here. Phi is equal to q by 4 pi epsilon 0 r square into this will be equal to 4 pi r square. Okay, so the 4 pi cancels. So what will you get? So 4 pi epsilon r square is there, r square also cancels. Okay, what will you get? You will get q by epsilon 0. This is q is a net charge enclosed by the surface and epsilon 0 is a permittivity of vacuum. So what's the total flux? Total flux is equal to 1 by epsilon 0 times the net charge enclosed. This is Gauss's theorem. So hence we have proved Gauss's law. Okay, now we can show that Gauss's law is related to Coulomb's law. How it is related to Coulomb's law? So what we are going to see is we see integral. See, we have the equation integral A into dA. A into dA is equal to, it is equal to q by epsilon 0. Q is the charge enclosed. Let us choose the charge enclosed is q1. See, now I consider as a q1 charge. This is the point. Suppose I place another charge here q2, r distance. Okay. Now we take intensity. We can take intensity. So this charge will experience a force at this point. What is the force experience? If A is the intensity, then force experienced by the charge is F is equal to, we have F is equal to, we have the relation Q into E. Okay, Q into E. Q means Q2. So what is E? E is equal to F by Q2. You can write F by Q2. Say we take E outside. Okay, at each and every point E will be constant. Now E outside. CE integral then dA is equal to q1 by epsilon 0. What is the value E? E is equal to F by q2. So F by q2. What is integral dA? As we have seen here, integral dA will be equal to 4 pi r for full surface area. It is equal to 4 pi r square is equal to q1 by epsilon 0. See, at this point we have placed another charge. This charge will experience a force in the electric field. Electric field at each and every point is uniform. So when you integrate, we can take electric field outside. Now F by Q2, electric field is F by Q2. So we just rearrange this. F is equal to, how will you get F? See, Q2 you multiply here, Q1, Q2. See, here we have 4 pi epsilon 0 r square. See, this is Coulomb's law. Force between the charges Q1 and Q2 is equal to, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square. See, then with the help of Gauss's law, we can arrive at Coulomb's law, the force between the charges. So we can say they are interconnected. Okay, I hope that you have understood. Thank you.